Yo, what's up everyone? We're back. We're gonna do another video. And this time we're gonna do a little bit of modularization. So last time we did the inventory system, we've done the crafting system, we've done the quest system, and now we need to simplify some code. So right now we've got our three systems here. They're all nice and cool. These ones here we don't really need to simplify. They're perfectly fine. However, on the client side, we do need to simplify some things. So if we have a look inside this interface here, we've got a couple scripts here, nothing else in solo player scripts there. However, if we go inside these, I'm going to open all of them. You'll notice that we have this here in every single one of them. So if we scroll down here, oh, this one doesn't have it because it's individual. If we go in inventory, this one has it. If we go quests, this one has it. So in this one, we're going to actually modularize this and make it so all three of these scripts access one module that has like the get data stuff. And on the server, instead of having this test script here, we can also put that in the module and have the server require the module inside, let's say, replicated storage. So to start this off, we're just gonna go straight in. We're gonna get a new module in replicated storage. We're gonna call this, I'm gonna call it like replicated data, just like I do in my framework. And the role of this is to replicate the data across the client server boundary. This is gonna be pretty simple. Let's just do the normal module there. Let me just stop that. So the idea here is that the server will require it, and it will handle the on-server invoke for the get data remote. And then the client will require that, and it will get the remote and then invoke it every whatever period of time. And then we can also make it so that server can invoke the client to tell the client to update the data immediately, which is another thing we can do. So how will we tell the client and server apart inside this module script? Is there some way? Yes, there is. Let's get the run service. So this run service has something called isServer or isClient. So if we just try that, isServer, isClient, and it will tell us if it's the server client. So for this one, we're going to use isServer. So let's just do an if statement. If run service isServer, then else. So now we have two different environments here. We've got the server and we've got the client. The client, let's say the client exploits and they try to override this. They can override it. However, they will not be able to do stuff on the server. It will only be client-sided for them, so it won't affect the server at all if you protect your remotes correctly. In our case, our remote is completely fine. All we just really do is say to the client, hey, you're trying to get your data. I'm going to return your data if it's there. Otherwise, I'm just going to return nil. There's nothing else going on here. There's no way for the client to tell the server to do certain things. So let's go back to replicated data now, and let's set this up. So what do these four have in common? One thing, the get data remote function. So we're going to need that remote. So let's just get that remote in here. I'm going to type it out. Typing it out is good repetition. So replicated storage, we want to get the remotes folder. Here's replicated storage, wait for child remotes. And then local get data remote function equals remotes folder, wait for child get data. So now that we've got the remote, let's have a look what the server does. So we'll do server first since it's the shortest, and we'll do the client afterwards. So let's have a look inside this test script. We have one simple on-server invoke, which is telling the client on their data. We just have to copy and paste it. Now we have another problem. We need to get the data service here. So how can we change this so that we don't need this data service, but the server can still put data in this module for the client to read? Well, let's make a function. So what I'm gonna actually do is here, function module set data. Actually, we'll do set private data for this one. And we'll do local player. Actually, I'll do it category data local player. And we'll just do set data. So here we're gonna say set the data, we're gonna have a category, we're gonna have data, and in this case we can have a local player or we don't have to have the local player. So local player is optional in this one. If no local player, then replicate to all. So that's the idea behind that one. So how can we do this? Well, let's just get rid of this for a moment so we don't have to look at it. Now we're going to have have our own loop to actually manage this because we're going to have to check if the data has updated. So one thing you can do is just do a task.spawn function. We'll need it immediately, so use task.spawn, not task.defer. And this will create a new thread which we can just run updates on. So we can have a like while task.wait 0.2 there. So every 0.2 seconds it will check for a data update. And what we need to do is loop through all the data. So we're going to loop through data, which we haven't set up yet. But we need to loop through all the data that's available to us, see if it's updated, and if it's updated, we want to replicate it to the client. So how do we do this? Let's create a table to put the data in that we're replicating first. So module.replications equals empty table. And here we're going to have private and public. So we're going to have two separate tables here. We're going to have private data for certain players. We're going to have public data for everyone. And that simplifies it a lot. So in this statement now, we can do a check for this local player. So if that local player is there, that means it's private data. If it's not there, it's public data. See how this is going? If local player, then else. So this is private data. This is public data. Now, obviously, if you're going to do it for specific players, you can actually change this to a table instead. That's up to you, though. Actually, I'll do it now. Let me do this. So if player table, then private data for a select group of players. So we won't do any checks on this. We'll just make sure you're doing it correctly. And then the public data is just, public data. Now, how do we want to set this? We just want to do module.replications.public. So this is public, this else here. The category equals data. So why do I want a category? So let's say we have player data, we've got like NPC data, and we need to separate them. Because if we don't have a category, they're going to be a mumble jumble, we don't know what's what. So by adding a category into it, we know what's what, and we can check for specific data values. So like if we have on the client a function get data, and we have a yielding option, we can make it so it waits till there is data before continuing the script or whatever. So we yield the script till there is data. So here we've got module.replications.public data, category equals data. So we're setting it to the public category for everyone to use. Otherwise in this one, we're going to do module.replications.private category. For this one, I might actually just use table.insert. So table.insert into the private data. We're going to have the category, the data, and the player table. So we'll have another loop in that while task.wait.2 that will check all of these here. Alright. So what's next? We need to have it update. So there's two ways we can do this. We should probably actually switch this remote from a remote function to a remote event, since we don't, like, if we fire or if we invoke client, we don't really need a response. We just want to tell the client the data. So here what I'm going to do is just change this to a get data, change it to a remote event. Actually, I'll call it data remote this time. Let's change that. Data remote event. And we're going to fire client. So this one is fire all clients. This one is for each of these player table values. If it's a player, we're going to fire client that specific player for every one of the players inside that table. So now that we've got that, so we'll do the public one first. So it replicates to everyone. So for public category, public data in pairs module.replications.public do. So we're going to loop through the data that's inside there. Now, how do we know that the data has changed? There's several ways to do it. I'm going to do the easiest way, which is to use JSON encode. So we're going to try convert the table that we're passing in to JSON. And then we're going to compare JSON strings. So JSON string, sorry. And that way, if you have like a JSON string, you can copy and paste it. And if everything goes correctly, you can actually load the data back in by using JSON decode. Some things to note about JSON encode and decode is you cannot encode instances, you cannot encode functions, you cannot encode user data. So user does like instance, functions, that sort of thing. So they have to be like string, boolean, tables. So tables will automatically like go inside another table. So like let's say you have two tables, one's inside the other though. It will JSON encode both the outer and inner one for you. So it's recursive. So we just have to worry about not passing instances and it will be good. Although it won't really do much to the script. So here we're going to have a table for a cache. So here we're going to do, so cache is a temporary data holder. We're just going to use it to compare old and new data. So local comparison cache equals an empty table. In here we'll have the category equals the cache string. That way we can compare. Now, one thing you can do is have it so you have a separate comparison cache for the public and private data in case you got player data in public and player data in private. However, for this one, since they're both going to end up being joined up on the client, it's going to be way easier just to have one table instead of having like this management system on the client too. On the client, it's going to get a lot simpler. You're just going to have one table with every single table that's being replicated to the player. So here, we're going to leave that note there so we know what's happening. We need to do two things here. We're going to do if... actually, we need to do another thing first. We need JSON encoding. So how can we get the JSON encode function? Through HTTP service is where you can get the JSON encode. So HTTP service, get service that. We're going to do local new encoded string, HTTP service, JSON encode the table, which is public data. And then we need two conditions in the if statement that we're about to do. We need to do one for checking if there is actually a comparison string inside there. And we need another one to check if they don't match. So here, what's happening inside this if statement is we're going to update the data. So we need to make sure in two cases, if there is no string, we need to update the data. If there is a string, but the string doesn't match with the new data, we want to update the data. So first one is if not comparison cache, public category. So if there is no current index inside the comparison cache dictionary for the public category, or no value for it, then we need to update it. Or if the comparison cache, so the currently stored string, does not equal to, so if they do not match the new encoded string, then we want to update. So that's if there's no string or if it's changed. And then we need to immediately set the new string equals new encoded string, and we need to update the data. So how can we update the data? Well, let's make a function. Function module update data, and then we'll pass in the category and the data. So that's important there. Actually, let's do player table too. So that way we'll have this universal for all of them. So now that we know that needs updating, we can just pass it through the update function there. Public category, public data, nil. So there's going to be no player table. Now, since we know it can be nil, we need an if statement in there. We'll worry about that in a minute though. But now let's continue on with the private data. So now we need to actually unpack the table, and then we need to get these individual values so we can check them. So here, so this is public data replicates to all. Now we want private data replicates to specific. For actually, we need to have a look here. So since it's an array now, so this module.replications.private data is an array, we're going to use ipairs instead of pairs. So for underscore, we don't need the index, but we do need the data or replication info in ipairs module.replications.public do. So, oh wait, no, we want private, sorry. So this is going to be this table up here with the category, data, and player table. So now we can just do unpack. Like call category, data, player table equals unpack the replication info. So unpack basically, if it's an array, it'll get all the values inside the array and it'll directly export it out of the table. So this unpack becomes these three separate variables in order of what they are stored inside this table. So if I change this data to be first, that means I've got to match the variables and have data be first. So that means data will have to go in front here. However, we want category first to make it neat. There we go. So now that we've got that, we can do pretty much the same thing we've done here. Copy that. So that's new encoded string. If it's non-existent, if the category is non-existent or the string does not match, then we want to set it again, and we want to update that. Just replace all the missing information, and there we go. And that's that for the while loop. We'll come back if there's any errors, but for now, let's jump to the update data. Alright. So if there is a player table, then we need to loop through each of the player tables and send them the data. So otherwise we can fire all clients. So we'll do this fire all clients first. We're just going to do simply fire all clients. We're going to do category, comma, data, and that's it. We'll make the client handle their own table on their side, which is what this bottom part here is for. Next, if there is a player table, we want to do for underscore. We don't need the index. For underscore, I like to use local player in ipairs. Player table do. We're going to do the same thing, except fire client to that specific local player, the category, and the data. And there we go. Alright. So that is pretty much all of that. We're going to also add a function to remove data. We're going to do category, data, player, table. Actually, we don't even need a player table. We don't need that one either. We're going to do so two separate ones for... Maybe I should have remove public data, remove private data. I might keep them separate for this one. Yeah, I'll keep them separate. Wait, no, they override anyway, so here we go. So if there's two matching categories in either public or private, once it reaches a client, it's going to merge. So we don't actually need to worry about that. So here we've got remove data of the category. We're going to do, we're going to actually check if it exists in here. If it does, set it to nil. And then we're going to loop through all of these for underscore replication data or replication info in IPairs. So it's an array. Remember that for private data. We're going to do if the first index, which is a category, is equal to the category, then now we're actually going to need the index. I forgot about that. We're going to table.remove module.replications.private at that index. So that underscore, change it back to a index variable name, like I index, something like that. And then we'll need that for table.remove. We're doing a lot of code right now, so make sure you're doing your spelling correctly. However, from the layout, you should be able to read it now and just double check it with double check and align, make sure it aligns with your code. But right now, we're doing pretty well with automated replicating data. And now we need to do the client side, which is surprisingly very easy. However, there's one more thing we need to do. We need to make a way for the client to tell the server that it needs data. Because we can do it when the player joins, but their side might not have fully loaded yet, which is a problem. Because if we fire a client, they might still receive it, but it might cause issues if you haven't had your other modules or other scripts load first. So what we want to do is make an option where you can fire server. So we're going to do data remote event on server event connect function. And this is going to be the local player that's firing the remote. And we're going to find all the data relating to that local player, and we're going to give it to them. So first and foremost, for each of the public datas, we're going to fire client, that specific local player, the category, and the data. And then we're going to go through the private data. We're going to get the category data player table. And we want to do if table.find. So if we can find the player inside the player table, then we want to send the data to them. And it's that simple. This is all logic, and we're following logic here. Now, obviously, I've done this before, so I'm kind of speeding through it. But I want you to go back and read through it, understand the logic, and you can do a lot of event stuff if you understand this. So, yeah. And there we go. We're done. That's the server done. Now let's go to the client. So, we won't specifically need this, but we still need to set up something on the server. So, for now, we'll just leave that in comment. And we'll begin on the client. So, on the client now, we need to have its own table, except we don't need private and public. We're going to have one joined table. So, local data container. I'm going to call it data container for the client. And another note is actually these variables are shared between the server and client side. So we can just use the same variable here, except we know that it's on the client now. So on client event connect function. We're going to receive something. Let's have a look what we receive. So we've got fire client. We're going to receive, so ignore the first one here. We're going to receive the category and data. So that's fire client, category data, fire all clients, category data. So it's always going to be category and data. So category data. And since we know that, we can do a direct set. Category equals data. So we're just going to set the value straight there. And now we need an actual function for us to use. So we're going to do function module. So remember the module tables out here. Some of you may be worried that these functions will go to the client in addition to these other ones over here. Do not worry. This run service is server will separate these functions. So this will only appear if run service is server. So only if that's true, it will create all of these variables here. There's no performance downfall by doing this. And only these ones will appear if it's the client. If it's the server will not see any of this. And it won't even load at that. So that's just a quick reminder. But let's continue. So on the client side, we want to create a function to get data. And we want to pass in the category. And in my case, I always love to add the option of yield, which means wait till the data is there. And we'll add a automatic timeout feature. So like if it's past 6 seconds of waiting, it will just return nil. So here we're going to do local so there's more than one way we can do this. We can do like if data container category, then return that. So if there is data there, return the data. Otherwise, if there isn't, so if there's no data, it's going to move on. If yield, then. This one's up to you how you want to do it. I always do like task wait 0.1 until it's there. And only once it's appeared, return that. However, this doesn't add the cooldown, which we're going to do. We're going to do yield start equals tick. You can use os.clock or tick. I'm going to use tick. And we're going to use tick to determine the time difference. So if I just print tick right now, it's going to print this big number. But if I print it again, you can see that it's actually incrementing over time. So 84, 86, 89, 90, 90, 90, 91. That's the time of... that's like a time value from a certain date in the calendar. So as this number, as real life time goes on, this number is going to also progress. And that's going to show a number since a specific date, as I said before. So we can use this to determine how long this has been running for, which is really nice. So we're going to say, repeat the wait until the data is there, or tick minus, so the current time minus the start time will give you a duration, and then we want to check that duration is larger than 5, and if it's larger than 5, that means it's timed out. We're just going to return whatever is there. So this can be a table, or it can be nil. So it can be either or. And now that we've got that, we can do one more thing, which is simply by server. Now, you can have it on its own like that. You can do like, if you get local player equals game, get service players dot local player. Do not put this on the outside here, because that's going to run for both client and server. However, on the server side, it's going to error, because this is not visible on the server side, the .local player. You're going to do it on the client side, so you make sure you do it in the else statement. So local player. So in one case, you do like local player.character added, connect function. So this here, so every event you do like this returns a connection. I'm just setting a variable for connection here. So that's another way to define it. The reason behind doing it like this is so that I can disconnect it immediately. Because if you try to do it like this, the variable is created as the event's being created. So you cannot actually disconnect a variable that hasn't been created yet, because the event's being mid-created and all that. So you need to define C first, and then you can set C to the event. And then that shortens to that line there. So you can have it like this. You can wait till a character is added. So like if you've got a load screen or something, you can do that. Or you can just fire server immediately. So, now that we've got that, we're going to actually change our server stuff to use this. So let's go ahead, go back to the script here. We're going to delete this test script. We won't need it anymore. Instead, we're going to go to our data service. And we're going to, on post profile load, that's one spot you can put it. Otherwise, you can put it inside this part here. Although I probably would put it on post profile load. That's probably a best spot. Or have another scope do it. Another option, if you want to, you can actually have it require the data service, but I would not do that. That's an easy way of creating a cyclic table, which is like a looping table. You don't want that. So what you should really do is require it in your data module or somewhere like that. Local replicated storage. Game get service replicated storage. Local replicated data. I'm just going to skip getting the folder. Equals require replicated storage, wait for child modules, wait for child replicated data. And then on post profile load. So that prints my inventory. Down here we're just going to do set data, player data, the profile.data. So not the profile, don't do the profile, use profile.data. You want to send them their data table, not the whole profile. And then we need to pass in a table, so that way it's for that player only, and we're going to pass in the player. So now that's saying replicate to this specific player their player data. Now, how can we test this on the client? We can use this on client event here. We can print the category. That's doing there. So if we print that, actually I don't even think it's yeah. So why isn't this working? Well, one thing is we've got to require the module on the client, and the other thing is these menus won't work because we haven't changed them yet. So I'm just going to disable all the other scripts, these quest, debug, and inventory one, once Roblox, unfreezes. And yeah, I'm going to require the module using a local script. So I'll make a local script inside starter player scripts, starter player. Let me just disable them. So down here, this is where I usually keep it. It's either called start or init. Init, I cannot use if I'm using Roho for Visual Studio Code. So I'm going to name it init since I'm not using Visual Studio Code. In here, we also need to require it. It's good to require it in your initializer one here. So local replicated storage, game get service replicated storage, local replicated data, require replicated storage, wait for child replicated, wait for child remotes, wait for child replicated data. You can combine this into one line if you don't want to keep variables there. But that's pretty much all you need to do. And then do the same here. I generally would put this one first. So that way this module's loaded when all these other ones load. In case any of these other ones need it. Which usually they don't. To get the data in these three, you would want to access data service. So that way the data service manages the table between replicated data and data service. Then replicated data replicates that to the client scripts. And then the client scripts do whatever with that data. They can't edit it, or they can edit it, but it won't affect the server. It will only affect the client. So now that we've got that done, we know it's being set there. So all we need to do is require it, which we've done, and we can test again. So let's test it. Let's see what we get. Alright. So we don't really know if anything's worked. So let's do some simple debugging, because doesn't seem like anything's printing right now. So we need to print something. So like I had it printing the data, but obviously nothing's printed. So let's have a look at what's happening. So here we got print data, print alert server. So this is print client started. It's like we're just chucking prints over to have a look. We've got print data update loop. Yeah. Print dot request from local player. Print public category. Print category. We get two separate categories there. Update data. We're just going to do category local player. Print category. This is sort of like it'll tell us what category is being updated. We won't worry about that one. Print category player table. So we know that's working. Print server. Print replicated data. Alright. Now we've got the prints everywhere. We should be able to see what's where. So replicated data, yep. Server, yep. We've got a play data on the client. So actually what the problem was before was that profile server is taking forever to load. Now we're actually getting the data. So we can see we've got player data there. That means we've got the data from the server, which is great news. So now we can have a way to tell our local scripts that we've got new data. How are we going to do this? We can use bindable events. Another thing to note is you can actually print the table. So for me right now, it does not print my table. It shows me table colon and the memory address. How do you fix this? Well, there's something called log mode, and I believe if you turn it off, that should just fix it. So if I run it now, oh wait, no, I gotta actually run the game now then. Let me stop that and then jump back in game. I don't know why this takes forever every time. It's infuriating sometimes. So let's have a look. So profile server is loaded, and we should get our data in a minute. Sometime. Okay, maybe not. So right now we can see it's... Oh no, there we go. Yep, so now we've got our data there. So, yeah, so that just took a bit to load. So profile service is having issues for me, but there we go. So now that we know that the data is working, let's set up a event using bindable event, and then we can have all our local scripts update based on that rather than a loop in each individual one of them. And since the table is the same directly from the server, we don't need to touch our scripts at all. We just need to tell them that the data is updated, and they can do the rest. So we can get rid of this now. We don't need it. We can get rid of all the prints. So since we know it works now, we can just get rid of the prints. I'll remove all of them. And then let's set up a bindable event inside the module. Function module on update equals instance.new bindable event. And then when we receive data, we'll simply fire category data. So this one's optional here, but I recommend you do pass in category. However, that should work now. Now we've got our replicated data fully set up, we can go to our local scripts and change them. So let's start with debug, because we can just copy and paste in the others. Active data is nil, and we've got an update function. Two things we can do with this. Get rid of that. local replicated data equals require replicated storage, wait for child modules, wait for child replicated data. So use wait for child to make sure it's there before it actually errors, trying to find something that's nil. And what we want to do is dot on update. Actually, quick thing here. See how it's showing you set data, get data, and all them. They won't be there on the client. It's just Roblox doesn't check if on server and all that, or if is server. So it will just show all the functions, but they won't be there. But this on update is the client one, which will connect. Since it's a bindable event. Oh wait, sorry. Since it's a bind event, we need to do .event, which is when that bindable event fire is called. We're going to connect that. We're going to get category. And we'll get new data. If category is equal to player data. So remember, there's more than one category, so we need to check the category. We can set the active data to the new data. And we'll run the task.spawn. Actually, we don't even need to spawn it. We can just do update. And get rid of all that. And there we go. Now that's going to work for any data that's passed through. And now we can copy and paste it to the others. And we're done. So get rid of that one there. For storage, wait for child modules. Let's clean that up. Active data. Get rid of that, copy that, paste that. So you can see how it's getting really easy now. Get rid of the get data. Let me bring them back down. We want replicated data. Modules photo of child replicated data. Get rid of this bottom one. Copy and paste this. And you can pretty much change this to all you need. Do quest update. Yeah, okay. Do quest update. Actually, I should probably on task.spawn. Does that require play data? Yeah. Alright. And then let's say you don't require this on update, but you want to get the data. What you can do is get data, player data, true. And then that's going to return that. So that way, if yours required straight away, you can just do that instead of using the on update. And actually, speaking of which, you could probably do replicated. Oh wait, no, replicated data. Get data, player data. You could probably do that and then do quest updated. Yeah. Yeah, so you have one that runs straight away and you got one that updates. So that's probably what you should be doing rather than what I showed you before. Update. That was pretty bloody intensive, wasn't it? But now that we've got through it, you've learned quite a bit. And actually, this is pretty close to what I have in my framework, except it's a little bit different. But wow, yeah. You can see how creating a system like this really helps. So now if we wait for our data to load, it should show at the bottom here. Hopefully it'll be quick. The video is nearly 50 minutes. Holy fuck. Any time now would be great. There we go. So our data replicates. If we click on one of these, it updates. And actually you can see it's a lot quicker now. Because it's every 0.1 seconds that it checks. We can craft items and it will still be quick. Let me just get some pairs. There we go. So yeah, that's replicated data. We did a lot of modularization. We did reduce the line count a little bit. Not too crazy. And yeah. So hopefully you've learned something. I sure did. I learned how to tidy my modules up again. I needed that a little bit. Tidy it up like that. But yeah, hopefully you've enjoyed, and let me know what you want next. I said this in the last video, I might do the sword combat thing in the next video. Since we've already cleaned this up a little bit, we can do it a lot easier. Actually, I wouldn't even need this in the sword combat thing, so it doesn't really matter, but you can see that we've got our modularized thing there. Everything is nice and neat. What we'll do next time is actually separate our modules. We're going to clean up the hierarchy a little bit. We're going to have like services. We'll have definitions, or like what's another word for it? Like configs or predefined tables. I don't know what you want to call it. Like, you know, values like this. Like, you've got configuration here, you got configuration here, but you've also got functions. So definitions probably work best. You got services, and then we can have like a hitbox service. You can have like animation service. We can do all of them. I probably won't do all of them, but you know, general idea. You want to set up a framework and get an understanding of how to do your own stuff like this. But yeah, hopefully you've learned a lot. I'll see you in the next video. See ya.